So in this video, we're going to talk about how to describe transformations of cubic functions. So the cubic parent function is f of x equals x cubed, and every other cubic function is a transformation of this parent function. So depending on the values of a, b, h, and k, which are constants, we're going to have different cubic functions. Remember that transformations come in three types. You can have shifts, which are also called translations, stretches or compressions, or reflections. So if we have a value of a, remember that's going to be a vertical stretch or a compression depending on what the absolute value of a is. It's going to be a reflection over the x-axis when a is less than 0. If you have a value of b, if the absolute value of b is less than or greater than 1, you can have a stretch or a compression, and it'll be a reflection over the y-axis when b is less than 0. So for h, we're going to have a similar situation as we did with the cube root functions. If it's less than 0, it's going to look like a plus sign in the problem, and that'll be a shift left. If it's greater than 0, that'll look like a minus sign in the problem, and that'll be a shift right. K is on the outside, so that's going to be a vertical transformation. It's going to be a shift up when K is greater than 0 and a shift down when K is less than 0. So this chart is in your study guide, so make sure that you refer to it as you're working through the practice problems. So let's look at this example. The function f of x equals x cubed is transformed to g of x equals 3x cubed plus 1. Let's describe the transformations. So notice that we have two new values added into our equation. We have this 3, and we also have this 1. So the 3 is on the outside, so that's going to be a vertical transformation. It's multiplying x cubed, so that means that we're going to need to decide whether it's a compression or a stretch. Well, the absolute value of 3 is equal to 3, and that is in fact greater than 1, so that is going to be a vertical stretch. So now let's think about the plus 1. The plus 1 is on the outside, right? So since it's on the outside, once again, it's a vertical change. Since it's being added, it's going to be a shift up because that means that k is greater than 0. So this is going to be a shift up. So remember, you can always graph transformations to make sure that you've described everything correctly. So here we have the parent function in blue, and we have the transformed function in red. And you can see that it is in fact vertically stretched and shifted up. So now let's look at this example. The function f of x equals x cubed is transformed to negative x plus 2 cubed. Let's describe the transformations. So we have this negative in front, and if you want to, you can think of it like a negative 1. And we also have this plus 2 right here. So the negative 1 is on the outside, right? So that's going to be a vertical transformation. It's multiplying. But it's not going to be a stretch or compression because the absolute value of negative 1 is 1, and that's neither less than or greater than 1, right? That's equal to 1. However, it is less than 0, okay? So what this is going to do is it's going to create a reflection over the x-axis. Now let's think about this plus 2. So the plus 2 is on the inside, right? So if it's on the inside, it's going to be a horizontal transformation. It's being added or subtracted. Notice we have that plus sign, so that is in fact going to be a shift to the left. Okay, so it's going to be a shift left 2. And let's go ahead and graph in Desmos to make sure that we have what has been described. So you can see x cubed is the parent function in red. Negative x plus 2 cubed is the transform function in blue. And you can see that it is in fact reflected over the y-axis, and it also is shifted to the left 2. So now you can go ahead and pause the video and try doing this problem on your own. So you can see here we have 3 new values that have been added in, right? We have this 2, we have this 3, which is a minus 3, and we have this plus 1. So based on the position of these values, you can see that the 2 creates a vertical stretch, minus 3 is shifted right 3, and plus 1 is shifted up 1. So if we graph in Desmos, you can see in fact that the transform function, which is in red, has been vertically stretched, shifted to the right 3, and it is shifted up 1.